Okay, so with this exam
table
question,
8 below shows the
it says
information
the table below shows
about three
information
matrices.
about 3 matrices.
So the transpose of matrix A,
of
for
matrix
example,
A,
is
for
written as
example,
A
is
to the
written
power T.
as
So they just
AT. Now,
gave
we
you
already
that
saw that
fact
yesterday.
because it might not
we
be
referred
known.
to, so they're just
Now,
reminding,
it says,
or they're just
what is
stating
the
that
order
it's going to be called that.
of the
So
product?
it's saying, product means saying to find what is the order of the product, and it's written there. So if you have a look at it, we need to follow our BODMAS normal things. So if you had an equation like that, or you're working that out, what would you do first?
Brackets.
The brackets, good. So we're going to do the brackets first. So what we're going to do, we're just looking at the order though. So if we look over here too, I'm going to just, we have to use transposed A. So let's just write down the order of transpose A. Now remember, transposing means you flip the rows and columns. So if the original matrix is a 2 by 4, then the transposed A is a 4 by 2. And we've also, while I'm here, I'm going to do transpose T because that's down in my question as well. So it's going to be a 4 by 3. So the first part I'm going to do is I'm first going to do that matrix A transpose multiplied with matrix B. Now I'm just looking at their orders because we're only interested in the order for the answer. So if I wrote down this one's order, it's a 4 by 2 and B is a 2 by 3. So if I did that multiplication, so in the end, really I've got this. What would the order be? It'll take that 4 and take that 3, won't it? Because it is defined, okay? It can be done. So the order of that, the multiplication inside the brackets is going to be a 4 by 3. Okay, so then the next thing it wants to do is it wants you to transpose that answer. So we want to transpose this answer here. So when we transpose that, that means we change the order around. So now it's become, if I transpose that one, it's become a 3 by 4. All right, so we've done all that bit now, and so now we've just got to multiply the C in front of it. So what we would have is the C. So if we put the order of C in front of it, it's a 3 by 4. What have I done? Oh no, transpose T, sorry. We want the transpose T. So, because it wasn't possible, was it? So change it around, so sorry, a 4 by 3. So yep, it's defined. And what would my final answer be? A 4 by 4. So the final answer is a 4 by 4. Okay, so matrix A has 3 rows and 2 columns. So always good to just sometimes people are more visual, definitely if you're for maths. So I like to write it out. So I know I've got a 3 by 2. And then it says matrix B has 4 rows and 3 columns. So 4 rows and 3 columns. And matrix C equals B times A. So C equals B times A. And then it says, so they want you to obviously tell the order of that multiplication. So if I wrote them out, it'd be 4 by 3 and a 3 by 2. Yes, it's possible. And my answer is going to be the 4 by 2. So C is going to have 4 rows and 2 columns. That's easy. Okay, with this one, the West Holland Council must prepare roads for expected population changes in each of the 3 locations of the main town, villages and rural areas. The population of each of these locations in 2018 are shown in P 2018 below. So the expected annual changes in the population in each location are shown below. So write down matrix P, which shows the expected population. So really all you've got to do is up here, when we want to increase the main town by 4%. So that means you've got to times this one by 1.04. When you need to decrease the villages by 1%, you would times this one by 0.99. Okay? And then the last one, when it says decrease by 2%, so we're going to times that one by 0.98. So you can just do that however you want to. Just grab the numbers, times it by that, and write it out. They're not asking me to do any matrix multiplication. Just write the matrix out. So I'll do that. Okay, so we've done that on our calculators, and we've got that. Now it says the expected population in each of the 3 locations in 2019 can be determined from the matrix product F by 2018. All right, so they want you to calculate F. So if we just, I'm going to write up here the statement they've got. So they've got P, matrix P 2019 should have been found, can be found by doing F by P 2018. So if we just think about their orders, we've already written what 2019 should be. And if you look at its order, it is a 3 by 1, isn't it? And we know 2018 is also a 3 by 1, so we're going to do that. So if the multiplication in the first place is possible, that means this F would have had to have a 3 there. And because my answer has a 3 and that one, it also has a 3. So you know that your F must be a 3 by 3. So maybe we will put, we're going to draw out a 3 by 3 scenario so that we can see what we've got to do. So we're going to have these 9 answers, and what it's going to be multiplied with is the 2018 one. Okay, so we're going to multiply that with the 2100, the 1800, and the 1700. And what it's going to produce is the answer we just found before, 2184, 1782, and 166. So you know this number here, the top one, this one here, we multiplied it by 1.04. So when you think about, if you think about the run and dive method or whatever, this one we would have gone this row down this column would have given this first answer. So we want that 2100 to be multiplied by 1.04. So that first number there will do that, won't it? You'd go 1.04 times 2100. Then you're going to multiply the next 2 numbers with whatever's written there. But I don't want them to show up, so I'll put a 0. So can you see, I'll draw this answer out for you. We'll show you how that would have been found. We would have done, if we did run and dive, that would have been 1.04 times 2100 plus 0 times 1800 plus 0 times 1700. So can you see I'm only affecting that first number, aren't I? Yeah? So if I put zeros elsewhere. Now in the second one, we want this second number, we want this number to show, and we want to multiply it by 0.9. So when we do run and dive, I don't want anything to do with that first number, but I want to influence when I hit the second one. So I'm going to put 0.99 and 0 there. Okay, so if I did that calculation there, it would have been 2100 times 0. Oh, sorry, I'll write it the other way. 0 times 2100 plus 0.99 times 1800. Yeah? Plus 0 times 1700. So you can see I'm only influencing that second number. Alright, so we're going to do this last one. So we want the last one here, if you remember at the start, we want this 1700 to be multiplied by 0.98. So it's the last number in the column. So it'll be the last number in the row that we see the 9, 8. And the other two, we want to have the 0. So if I just showed you how that came about, I'll do it here. It would have been 0 times the 2100 plus 0 times the 1800. So that's not going to influence, that's just going to be 0. And then finally I'll have 0.98 times the 1700, and that will show that. So that's how that works. So we probably have to answer the question finally. So they said write down. Now it gave it away too. It said that it was a diagonal matrix. So a diagonal matrix is a square matrix. So what does that mean? It's a same rows and same columns, which is good. We worked it out to be a 3 by 3. And if we wrote out our answer there, so 1.0400, do we only have numbers on our leading diagonal? Yes, and that's what makes a diagonal matrix, is numbers on the leading diagonal. So we can definitely know we're right. Okay, there are 2 rides called the Big Dipper and the Terror Train at a carnival. The cost in dollars for a child to ride on each ride is shown below. 6 children ride once only on the Big Dipper and once only on the Terror Train. The total cost of the rides in dollars for these 6 children can be determined by which of the following matrix. So what you've got to look is, this one's pretty easy, but what they want is a matrix that shows the total cost of rides. So if you had a total cost of rides, it would be just one answer like that. So that in matrix would be a 1 by 1. Would you agree?
Yes.
Yeah? So you've got to think about that straight away. You should see a matrix multiplication that gives you a 1 by 1. So if you look here, we've got a 1 by 1 with a 1 by 2. Is that going to give it? No, get rid of it. What about this one? 1 by 2 and a 1 by 2. So no, out. This one, 2 by 1 with a 1 by 2. That answer will give a 2 by 2. So that one's out. It's defined, but it's not what my answer is going to be. Here, I've got a 1 by 1 with a 2 by 1. It's not even defined, is it? No. So finally, I've got a 1 by 2 with a 2 by 1. This is defined, so it can work. And my answer will be a 1 by 1. I don't even have to work it out because it was the only answer anyway. The 4 matrices are shown below. Which one of the following matrix is not defined? So if we put the orders underneath here, so we've got a 2 by 3, 1 by 2, and 3 by 3. Okay, so if we look at W and Y, that one is defined because I've got a 3 by 1 with a 1 by 2. So that one's defined, it's not the answer. If we look at X, we've got a 2 by 3 with W, which is a 3 by 1. That one's defined. X, we've got a 2 by, Y's first. So we've got Y first, which is a 1 by 2 with X, which is a 2 by 3. That one's also defined. Z, we've got a 3 by 3 with W, 3 by 1. That one's defined. So hopefully this last one is not. Z is a 3 by 3 with Y, a 1 by 2. So these ones are not equal, not defined. There's the answer. Okay, so question 4. The table below shows the number of type of coins saved in a money box. The matrix product that displays the total number of coins and the total number of values of coins. So here where it says total number, you want the total number of coins plus the total, and so that means you want another answer that has the total value of these coins. So really you want to have a matrix that's going to have 2 elements, because it's going to have one element will be the total value, and the other element would be the total number of coins. So you at least know that. So if you have a look, we want to end up with we either want to end up with a 2 by 1 or a 1 by 2, because that's would have 2 elements. So if you have a look, we could quickly eliminate a few. So here we have a 1 by 4 with a 4 by 1. So would that end up with a 2 element in it? No, wouldn't it? This one would end up being a 1 by 1. Oops, sorry. A 1 by 1. So we'll get rid of that. That's not an answer. So, and we could get rid of this one, D2, because we know it's going to produce the same. All right, so then if we look at, let's look at this one. This one is a 1 by 4 with a 4 by 2. Well, this one's good, because if I multiply this one, I'll end up with a 1 by 2, which is what I want. I either want that or that. So let's have a look. If we have a 1 by 2, we'd end up with a matrix that has 2 little answers here. So if I was going to go and find out this first answer, what it would be is we'd be running across here and going down like that. So when we saw, remember yesterday, if we multiplied by a column matrix of 1, it added up the row. So if I was adding up those rows, that would give me, wouldn't that add up the total number of coins? Yes? So that's good. That would give total, this is number of coins. And then if we did this next one over here, you'd go run and you'd go dive. So what would be happening? I'd be going 15 times 5. Now, that makes sense because I've got 15 5-cent pieces. And then the next one I'd be doing 32 times 10, which is thing. So that's going to add up the value in cents, isn't it? Yeah? When we go across. So this one will give you the value. So this B ends up being the answer. If you look at the other ones, it won't work because this one here, this is just adding up the just if you had 1 5-cent piece, if you had 1 5-cent piece and all that. So that's the one it works. So this, what I'm saying is you need to work out what your answer needs to look like, and it can help. You could obviously go through them all and find one that has the answer, because it's pretty logic to find the answer, what it is, the total value. But that just takes too long. That takes you longer than someone who's quickly trying to work it out with just using it. Okay, which set of equations below could be used to determine the values of A and B that are shown in the matrix equation above? So what you need to do is, if you were multiplying, you've got to look at how the things, and this is where multiplying is going to come in terms. So if we just did this front multiplication, so we've got a 2 by 2 and a 2 by 1. So what would our answer be for that? It'll be a 2 by 1. Are you happy with that? So what I'm saying is we would have taken this 2 and that 1. That's where we get our answer. So I'm gonna fill in that answer here. So I'm gonna have 2 rows, and so row 1, row 2, and 1 column. So if I do the first element, it will be run and dive. So what will be written there would be 3A plus 4 times 3, okay? And then if I do that second row, it would be row to run and dive. So it would be 1 times A, so 1A, I'll leave it as 1 for you, you can just write A, plus 2 times 3. Okay, so this is, I'm just doing that left-hand side. So if I tidied that up, it would be 3A plus 12 and A plus 6. Okay, this is that side of the equation. And then if we go and do, we're going to say it equals, let's go and do this side of the equation, which is still the same. It's going to be a 2 by 1. Still going to be a 2 by 1, and we've got, this is row 1, row 2. So I'll do it again with the same colour. I'll do the top one purple. So there we go. We're going to have 6 times 2 plus 3 times b, and then in the second row by second column, we're going to have 2 times 2 plus -1 times b. So if I tidy that up, that would be 12 plus 3b, and then 4 minus b. So they're saying what equations could you say? When you have matrices that equal, that means I can say that top element must equal that element. So I could write 3a plus 12 equals 12 plus 3b. And then I could write the other one. I could say a plus 6 equals 4 minus b. So what they've done is they've just rearranged all the equations, and you can type that in. So really, if we go like this, I'm going to rearrange this one. If I put the b on the other side, on that side, we would have a plus b equals, and I'm going to move this 6 on the other side. So for some of the general kids, you haven't done as much algebra. So you get a plus b equals -2. Is that an option in any of them? Yeah, it's here. We've got a plus b equals -2 and a plus b. No other one has. So then we've got a minus b equals 0. That would be true if we rearrange this. If you've got 12 plus, if these two sides equal each other, can you see that a must equal b? Does that make sense there? See here, because they're exactly the same, isn't it? There's a 12 and there's 12, there's a 3 and a 3. If those both sides equal each other, a and b must be the same number. So we could, what have we got our options are? So I'm going to say, all right, we've got to have to, so what you could do is, let's just find a. No, it doesn't have to be. I'll just pause this. I'll just say that. So we ended up rearranging this one. And then we got this. And then because it doesn't look like any of the other ones, we've divided it by 3 on both sides. And because we've done it to both sides, it doesn't make a difference to the equation. So then we ended up with a minus b equals 0. So that's how we got the b. Okay, so the matrix product, this matrix by this matrix is equal to, this is easy, it is question 2, but I'm just going to show you, let's do it manually to practice. So we've got a 1 by 3 and a 3 by 1. What would our answer be? A 1 by 1. Actually, I'm not even going to do it because what's our answer? What's the only one that has a 1 by 1? Oh, actually, though, we have to be careful because the others might produce that, mightn't they? So let's just check to see. If we did this, so we're going to get a 1 by 1, we would have 4 times 4 plus 2 times 12 plus 0 times 8. So that would equal 16 plus 24 plus 0. Does that equal, what does that equal? 40. So is that the first one? No. So that's not our answer. So we need something that equals 40. This one definitely not the answer. Okay? So now these other ones could produce it. So we have to be careful. So here, this first part, let's go do these. So the first part here is a scalar. So I'll do that first, and then I would have 4, 8, and 0, and then I'm multiplying it by this one, 1, 12, and 8. Well, so we already know that wouldn't give that, so we can say that's out. That's not going to work. If we do this next one, if I just do the scalar, I'd have 4, 2, and 0, and I'd be timesing it by 2, 6, and 4. That already looks different to up here, so I'm not going to say that's it. And then the last one, we'd have 8, 4, and 0. multiplying by 2, 6, and 4. So let's go check what that one produces. That one would be 8 times 2 plus 4 times 6 plus 0 times 4. Okay, we need 40 here. So what do we get? We get 16 plus 24 plus 0. Is that 40? Yeah? So we got the same. So this one's our answer. Okay, we've got A, B, and the matrix A, B. So they've multiplied A and B. The element 24 in the matrix is obtained by calculating. So this is where the calculator won't tell you. The calculator's already told the answer here. So this is where you have to know. So you know you multiplied, A got multiplied with B. So this is what we did. And this bottom element, so it is in row 2, column 1. So we used row 2 and we used column 1 to obtain the answer. So what happened there, so remember we go run and we dived. So we would have done 4 times 3 plus 2 times 6. So is there, that answer's there? Is B. Okay, so the price in dollars of 3 different televisions and 3 different brands in a major retail store is shown below. The retailer is about to discount product A by 10%. So let's start thinking about that. So if we're discounting product A by 10%, just remember that means we would be timesing it by 0.90, yeah? Because remember, if you discount by 10%, that means you 10% discount means you would be doing 1 minus 0.10, which is 0. That means you're timesing it by 0.9. Okay, and then it says it's going to discount brand B by 25%. So what would we be timesing that by? Yeah, 0.75. And then the last one, brand C, by 15%. So what would we be timesing that one by? 0.85. Yeah? Okay, so that's what one. And it says, which of the following matrix equations would give the discounted price in dollars for the 3 different brands of TVs and the 3 different sizes? So in the end, you do want all these numbers there, but in their new pricing. So what you want, your answer wants to be a 3 by 3, doesn't it? Yeah? Because you want the 3 brands, the 3 prices with their new pricing. So if you have a look here, we've got a 3 by 3 with a 3 by 1. What answer is that going to produce? A 3 by 1. So I'm going to say that's not the combination I want, and I'm going to go get rid of the other one that looks like that as well. So you can see my only other options are all the same, a 3 by 3. So we'll have a look at it. So really, if you have a look, you go, when you multiply this out, you can see here, this is the sizing along here and the brands along the top. If I just went, so I would have a 3 by 3 answer here. If I just went to go and find this answer here, or actually I'll do it red, this answer here, because that answer there is going to be the 40-inch A brand, and it's going to be 800 times the 0.90. That's what I want there, written there, the answer to that. So if you look, if we go along here, and we would find that by going run and dive. So when you see that, I'm actually timesing the 800 by, if I did this one, if I do this calculation here, it says that I would be going 800 times 0.10 plus 750 times 0 plus 920 times 0. So it's good that it's only affecting the 800, but it's doing it by 10%. So that means it's only showing me the discount. We want the new pricing. So that one's not on, but it's a good combination. So which is the one we want then? We want E, don't we? down here, because you can see this, when we do that, this is going to multiply only the brand A's by 0.9. And then if you do this column, so say, for example, we had our answer. So if I did this spot here, the middle spot, I would be going run and middle column, and you could see the way I calculate this would be 800 times 0 plus 750 times the 0.75, which is good, plus 920 times 0. So you can see it produces the answer that you want. Okay, question 5. Matrix A is a 7 by 7 and B is a 10 by 7 matrix. Which of the following expressions is defined? So, first of all, can we do matrix A, can we multiply matrix B? Because that's what they're asking me to do here. So we've got a 7 by 7 with a 10 by 7. Is that defined? No. So we can't do AB. So we can't do that one, and we definitely can't do... all right, well, let's just think about that one. We can't do that one. So let's have a look here. If we're doing this one, can we do B times A? Is that possible first? Because it's inside the brackets. So we've got 10 by 7 with 7 by 7. We could do that one, couldn't we? So BA would produce A 10 by 7. Okay, then we're going to... Then what it's asking me to do is raise it to a power. And this is going into what we're going to do today. You can only raise a matrix to a power. So we might rewrite the note. It is going to come up in our notes, but we're going to write it here. Only square matrices can be raised to a power. Oops. Probably don't need the S there. Only square matrices can be raised to a power. So even if it's power of -1, raised to a power. So I can get rid of that answer too. That one's no good. Now, it says AB squared. So what they've done there first, if they tried to square B, it wasn't a... B's not a square matrix, so I can't have it to the power of 2 because we can't raise... we can only raise a square matrix. And if we looked at AB wasn't possible. So even if they wanted to square that whole thing, it wasn't out. So we'll get rid of that one. Now, can we square, first of all, can we square A squared? We can. We can raise it to the power of 2. So that one would be, so if you did A times A, obviously you've got a 7 by 7 multiplied with a 7 by 7. What are you going to get? The answer will be A squared is going to be a 7 by 7. Okay, does that mean, and we already looked up here, minus BA. What did we know about matrices when we try to add and subtract? They need to be the same what? They need to be the same order. So we can't do that, can we? Because that's a 10 by 7. We've already worked that out. That you cannot do, because they're not the same order, so we get rid of that. So hopefully this last one would work. So A is a 7 by 7, but they want me to multiply it with B that's been transposed. So B transposed means it flicks around and becomes a 7 by 10, which means it is possible, isn't it? So E is our answer. E is defined. Okay, just to quickly go over these students' tips. It says, like, the examiners write a few little notes. Students may need to be able to articulate why two matrices may not be conformable for multiplication. So you need to be able to say, what that means is you have to be able to say matrix A cannot be multiplied with matrix B because the columns in A doesn't equal the rows. That's that statement I was saying yesterday. And it said, many students have illustrated poor understanding for the need of the number of columns. So see there, they're telling you that's what you need to have, the number of columns in the first matrix equal to that. All right? don't, and then it says underneath, don't use that equal sign. That's not going to count.